Hello, today we have two city scheduling. All right, we have a company is planning to interview two N people. Given array cost, the cost I, the cost of flying each person to city A, and the cost of flying to the city B. Return the minimum cost to fly person to a city such that exactly N people arrive in each city. Okay, so we have two N and we need return the minimum cost. The first person goes to city A, the second goes to city B. Minimum cost half of the people interviewed in each city. Okay, so we have a costs which is so first idea I can iterate costs and if costs zero more than cost one, right? Then and also we declare we have to return minimum cost for every person to a city with exactly n people in each city. So first person 10, second person goes to city 8 10, second one is 15 and 20. Yeah. So and we return minimal cost which is okay, so we declare result. So if C zero, we add result plus C zero, right? Else we add the result um, to C1 and we return the result. Let's consider second example. So this is the cost 250. So in second example, if we just print 75 plus 50. Oh, but we cannot. Um, we have to have n into each city, right? So we have to. Oh, I understand what this means. So consider this: if we use this solution A and we only add to city n, there is a cap on amount of people flying to city n. We cannot add indefinitely city 0 or city 1. We have to add on the first one, right? First, you can we can only add n. So down the road, we must know which city we should. Okay, so how about this? We split array into if we split array into hash map, saying like with means like some kind of structure, have to sort it, without losing index. So what if we create hash map like city1, which will be dictionary with or I can use dictionary with a b, which index is and cost, where so for e cost in enumerate so it will be like city1, city2, right? How about we have a so imagine we have but we have to have a sorted them in group in one, right? Returns the minimum cost. For example, we have city1, then we do sorted. So what will be, my question is, what will be easier way to solve this, right? If we have most optimal input parameters, what will be easier way to solve this? Like what will be easier incoming parameter? So obviously, you have sorted array person1, city1, person to city to person. And then wait, like cost 1 and city 1, then cost 2, city 2, and this is sorted in one list from from smallest to higher, right? And if this is sorted, then I can go and then add it. I can then my algorithm solution A will work, right? I will go. However, here I have to do. I have to do count. Iterate cost until n until count equal n. So I can do like while n no, I still need iteration. So here I can increase count, and if count more than n, then count equal n, then I return this. That's it. But it doesn't matter. Index doesn't matter. So how about if I just so to get this, how about I just sort it? I can say C is sorted with sorted costs with lambda x. Yeah, but I can sort if oh yeah. So I need this cost city, right? Let's. How about if I convert this array into for so for city1, city2 in costs, I can create like array C, and I can add, and also I can add C, add, right, or C append, and we append two arguments. We append ct1, c1, and we append ct2, c2. Then we sort. Let's call it solution B. Then we sorted. Now, oh yeah, now. Let's call it sorted cost. In C, and we have S1, C1. No, it's not how sorting works. So sorted, we sort in C and we add in or key. Can we add key by sorting, or this is lambda? Okay, yeah. So we can add key equal lambda, and we sort by cost, which is second on the x2 0 1 0 1, yeah. And these give us this sorted array with cost first, no matter which CT cost will be first, and then I run through the this algorithm and select my my result. Yeah, let's go and quickly implement this. So we declare array, we go through the array, and we go through the cost, we created sorted cost, then we declare result for we declare counter, then we use this, and for in range of 2n, which is, let's do len sorted cost. We need to add sorted cost here, obviously. If it's less, then we add but one question is, if we have this, right? If we reach n, what does it mean? Does it mean we reached n1 or n2? We have to declare like c1, ct1, ct2. Okay, let's call it ct1, ct2 field, and here we add. If we doing ct1, right? If we add in ct1, we increasing. If also we have to have two results. Result 1, result 2, CT2 increasing, then if CT1 equal n, we return result 1. And if CT2 equal 1, we result 2. Okay, that's good. We check it. Oh, we haven't defined an end. N equal length of costs. And okay, I will leave it. It definitely should be 2n, but I will leave the sorted cost. Okay, let's try and run. Oh, yeah, just we didn't. Okay, so let's do even everything, and then we need even this. Okay, runtime expected is what else? If sorted cost. But see, sorted cost is not like that. Sorted cost has a CT, right? And cost. So what I'm going to do, sorted cost is 0. If sorted cost 0 equal 1, that means it's CT1. Else, I just add to CT2. Yeah. Not enough layers to unpack. Oh yeah, I have to add more. Yeah, so sorted cost I. No. Sorted cost I0, sorted cost I1, sorted cost I1. Okay, so I will have to, I don't understand why I have to print sorted cost. Yeah, so we add 1, we add 2, we add 2, we add 2. But how about we remove this? We remove this and we at result, we will Mm. So we add 10, we add 20 to CT2, 20 to CT2, we add 30 to 10, so let's run it through. Plus 1 equal 10 plus 2 equal 20 plus 13 plus 13 plus 13. So the n equal 1, 2, 3, 4. N equal 4. 10 plus 20 plus 30 plus 13 plus 15 plus 200. Oh, the result caused by every percentage teaches exactly n people are in each city. So total people in both cities arrive. Yeah, I guess so. So I have to keep counter n. Okay, let's do another counter. Let's keep total. Okay, total plus 1. Oh, we add in for different cities. We add in the same result. Okay, yeah. So initial thought. So sketch that. But this is still valid. My solution is still valid. The thing is, I have to um, do it differently. So result equal 0. Um, amount people equal 0. So we add result here, result here. We add amount in any case, and if amount equal n, we return result. So we add 10, we add 30, we add 50. So we add, total is 4. So we add 10, we add 20, we add 20, we add 30. To have half of people entering in each city. Oh, okay, so half and half in each. So it should be n by 2 in each. Oh my god. Okay. Let's do the thing again. So result one, two, amount one, amount divided by two. So if costs if amount by one plus amount one. So we have to define n by two and with two we call it n two. Then so amount let's just call it n two and amount one less n two. With amount one less n two. We have some here. And here we say if amount one equal n amount two equal n return amount one plus amount two, I guess. No, invalid expected return type integer. Maybe return none. Okay. Yes, one, two. There is one. Oh my god. Yeah, obviously we don't have to return amount, we have to return results. Still empty. Okay, oh why? So we have 10, we have 30, we had 10, and we had 30, which is 40. We had 20, we had 20, which is 40. Total amount to fly 4 people. Oh, but we cannot choose like this because we can choose only between. Okay. Yeah, I guess I failed this. we can choose only between. We cannot choose like this from here. See, I cannot choose 10 and 20 because this is failed index, right? So if I can do iterate cost and I can add enumerate, sorry, enumerate cost and I can add index, right? And then I can append index. Then I have to sort by second one, and then I can create um, used as a set. And if I when I select, okay, let's add index again. Doesn't matter for us. I just need to sort it by this, so I don't have to change this. However, if I'm choosing this, I need to add use it. So if sorted equal one, and so let's unpack this. Like following, we unpacked to index, dx index, we unpacked to cost, and we unpacked to city, cost, and index, right? So if like 10, 20 is together, so I cannot use 10 for CT1 and because this is the same person. So index is a person. Let's call person. Then I do what I can do. I can if CT equal 1, right? And amount is less. I add cost to travel into CT1. I increase amount and I do used and person. And no person in used. So I can say if person in used, I just continue. We continue a cycle if person already traveled. So we don't have to worry about this. So then if CP equal 1, I add, and here I add person 2. And here I add cost. And here I count in amount of person travel. Okay, let's try this. Okay, I add 3 events the whole thing. It's kind of complicated, but I'm gonna make it. All right, these 2 cases. Why this one is not working? I wonder. So let's print sorted cost. So we have person 2 for 54, right? Then person 2, person 4 in 118. Also in city 2, okay? Okay, why it's not catching this problem? So since this is why I have this, it means person 1 must travel to city 2. And I am adding person 1 to city 2. Then same person 4 must travel to city 2. And adding to city 2. Person 3 must travel to city 2. And I'm adding city 2. Then it's saying person 3 also can travel to city 1. I think this is what's going on. So instead of greedy, it should be backtracking. Is it backtracking? No, it's greedy. So like I should consider traveling this person to person 3 to city 1 instead of city 2. Okay, what I can do, I can call, hmm, see it like this. Which one should we choose? City 1 or city 2? Like, or should we calculate like total amount of traveling? Like obviously my algorithm choosing city 2 here. Person 3 goes to city 2. But maybe person 3 should go to city 1. To city 1, and then city 1 will be smaller. Maybe it's not 50-50. Maybe it's total. I mean, how about that? Nah. To have half of each people, half of the people. Okay, yeah, I think I tried a couple algorithms. Um, it's 49 minutes. So yeah, I'll have to take a look at solution, and because at this point I don't know how to solve it. All right, that will be it for today. Thank you for watching.